Very kind introduction. So I'm Andrew McCalip from Varda Space Industries, and I'm here to talk about Project Bob. So Project Bob is one of my hobby projects. It is a unmanned, solar-powered craft, a small boat that we're trying to take around the world. So it's circumnavigation or bust with open source tools. So we've only got 15 minutes for this, so hold your questions to the podcast that comes right after this. We're going to go through this pretty quick. So this all started with a Twitter post, and I do a lot of things in public. I love building these hardware, software projects in public, live, and it's been a ton of fun. And so this one kicked off like 7 months ago, and it got a little bit out of hand. We did a Kickstarter project, and it got funded in a day, and so this is the result of that. So I'm going to give a little background, like how did you end up choosing an autonomous boat? So as background, my day job, as you can see, is building satellites and spacecraft. So these are really just essentially really expensive autonomous boats. It's all the same systems. You've got propulsion, you've got batteries, solar, RF comms, compute, all the same things. And so I do this as my day job. I build infrastructure. I build the hardware and software to test the hardware and software. So it looks like a very similar set of problems. You've got a bunch of I/O, a bunch of pressure transducers, temperatures, lots of things to monitor, bidirectional comms. And so my day job is to assemble hardware and software to test this vehicle. So this is a satellite bus we launched into space, and you saw it come back from space there, sort of like the Apollo capsules of old. And so that's what I do for my day job. And then, so the work knows me as the guy with the weird hobbies. The internet knows me as the guy from the LK99 debacle. And so this is where I got slightly infamous for doing another Twitter project, trying to replicate the room temperature superconductors. Also did it on Twitter. And this was a fun one, like trying to buy red phosphorus and trying to import stuff from Poland and building quartz reaction vessels after hours at work. And it didn't end up working. The science wasn't great. We ended up making some contributions. We donated our samples to a lab and got some papers out of it. But it was fun. We made some friends along the way. The key part about this, though, is that during the adventures, we had, it was like 15,000 people watching a live stream at one point where it was just a webcam looking at a furnace door with a Grafana temperature plot. And the whole entire internet was riveted. And so they gave me the idea, like, hey, can we do more really boring live streams? And so that was kind of the genesis of this idea is, can we do an orbit? Can we do a really boring live stream? And can we engage the public as we build with these cool tools? So the most boring live stream in history is Project Bob. So why has nobody done this before? Well, they have. And actually, I heard last night there's somebody at Grafana that has sailed around the world. And so find that person and congratulate them. We're doing this the easy way. I'm sending a pie around the world. I'm not going myself. And so we did this 500 years ago. Magellan did this. And so what does it take to circumnavigate? I use that word. It's like we got to go 25,000 miles. We have to cross the equator twice. We have to hit the antipode, which is the opposite side of the Earth from where you started. And we cannot use the canals. And so my route looks a little bit different than Magellan. We're going to go from Los Angeles, our launching point. We're going to go under South America, under Africa, under Australia, and then back to Los Angeles. This is all very optimistic. I don't think that we're going to make it the first time, but we're going to keep trying until we get it. This would be a world record if we can pull it off. So before I talk about the software stack, touch real briefly on the hardware. So this started as like an after-hours sort of hackathon activity where we had some engineers come together and build it up from first principles of how big does a boat need to be, how much solar panel, how big do the batteries need to be, how can we assemble this stack of parts. And so as we build the spacecraft, there's always a collection of tools and components that you would love to use in space, but they're maybe not space rated. And so you're always carrying around in your back pocket this cool collection of, hey, wouldn't it be nice to use these panels or these really great motors? So this has been a creative outlet for some of the engineers to get some of those ideas out of their system. So here's the progress of where we're at right now. So we've got two different designs. We've got sort of the more efficient one where we fiberglassed a hole, and it's sort of the sleek aerodynamic version. Should be way more efficient. And then we have the like rough and ready off the shelf where we've taken a kayak and filled it full of batteries and foam, and so this is the more rugged version, but it's going to be a lot slower. So it's a little bit of a race between the two designs. We're launching number 2 first, and then 1 will catch up later. So this is the point where this is like the Iron Man montage of where the hero spends 20 seconds and there's fast-paced music and it all just comes together really quickly. In reality, it's been like 6 to 7 months of nights and weekends and come into work an hour early and do a little bit of wiring. And you can see us doing PCB work, riveting on panels, building wire harnesses, welding up the keel. It's truly like a full stack effort. And so jump ahead to, we're on the water, so we've been out testing. So this is the culmination of like 6 months of work. And so this is the boat. It's about 14 feet long. It's about 300 pounds. And so I'll show some videos of it operating later. But yeah, let's talk a little bit about the software stack. So I'm a mechanical engineer. I'm not a software engineer, and so I had to learn all this from scratch. I haven't really done software in 10 years, so I come back, and after 10 years, there's this whole sprawling ecosystem of wonderful tools that wasn't there the first time. And so I'm super grateful for all of these tools that have sprung up. And so this is just some of the things that we use on the boat. And so real quick, touch on, and we can go into more detail later, but this is kind of the pipeline of the boat side and the land side. So on board the boat, we have a Raspberry Pi 4, and this is running a whole bunch of Docker containers. And so we've got, I think, 14 Docker containers now, and they do everything on the boat. They control the propulsion system, the motors, the stepper motors on the actuators, GPS, and accelerometers, magnetometers, IP cameras. So we have this huge collection of all these assorted protocols. And this is like a common theme in all my projects is it has to interface with real life. To me, it has to go out and touch something in the real world to really be interesting for me. And so Docker was a good way to isolate all these different protocols. And then what we do is we use Redis to communicate to all the Docker containers. So that's sort of our backplane of sensing and command. And then from Redis, we take it over to Telegraph. And so we run Influx on the boat. And we also have a Starlink. And so part of the idea, remember, was that this should be a live stream. We should broadcast as much as possible. And so we turn on the Starlink 6 hours a day, and we pull all the metrics off the boat. We replicate the onboard Influx database over to GCP. And we also transfer over all the videos that we've stored throughout the day. And then on the GCP side, what we do is we backfill our Influx database and then push that to the Grafana Cloud dashboards. We also reassemble all the video chunks, and because we chunk everything over Tailscale and Starlink, and then we reassemble all those chunks and do something kind of fun where we composite the Grafana dashboards in OBS over the video that we've collected from the onboard cameras, and eventually push that out to YouTube. And so it's this like convoluted pipeline, but it took a little while to write, but it's working pretty well. So, so testing, embracing the SRE culture of test everything, record everything all the time. And so this is us in our dev environment. So dev environment for us is like flat sat. We take all the parts, lay them out on a table, start writing drivers against those. So this is how the project started, like a month after the original post. And so this is us talking to motors, talking to GPS. I would wheel this outside and start writing all the drivers and all those Docker containers to talk to each one of these different devices. So then, as we got the drivers working and it's sort of stable, I climbed up on the roof of work and installed some solar panels, installed Starlink, batteries, and actually started getting some solar cycles. So we're actually powering the whole system, powering that Hiddle bench, and running it 24/7, and running Starlink all the time, and just collecting metrics and finding those long-term bugs that inevitably do pop up. So this one's kind of a fun one. You can see me Grafana-ing from the front of the truck on the way to the marina. And so there's even things like GPS where you can't really exercise it sitting in the back lot. And so took some of these rare opportunities to check my GPS heading accuracy and a couple other things as we're on the road. So I'm sitting in the truck. We've got Grafana open. We're streaming video through Starlink, through Tailscale, back down to the laptop as we drive down the 405 in Los Angeles. So that was kind of fun. I've got a couple strange looks. And so here we are, actually out on the water. So this has turned into one of my favorite dashboards. This is the FPV mode, how we drive the boat from the marina. So a couple things here. We are embedding video. So we've got live video from the forward-facing cameras on the boat, which is what you see there in the center. And then the standard button plugins for Grafana weren't quite enough. I needed to do a couple custom things. And so this is a fun hack that I've used now for all of my work projects and personal projects, starting to embed HTML elements in the dashboards to give them controls. So now with these controls, we can reach out, turn on the rudder, we can go hard starboard, we can go control the speed of the boat, power channels, and so that's with nice GUI and fast API, and that's been absolutely fantastic. And then of course all the standard metrics, tracking power and rudder angle and all that. But this one has been great for driving it around. We were pretty successful in the marina testing. So we've been out 3 or 4 times now. And number one goal was don't sink, and we did not sink. We did hit a few boats. There was some lag, and once we got out of range of the Wi-Fi, we lost Wi-Fi connection to the boat, and it ran away from us. But other than that, it's been good. Little iterations you find, like the rudder's too small, and other little mechanical improvements. And so this has been like a great test campaign. You got to get all the bugs out, because once we send this thing off, there's no way to ever get to it again. We've got one chance, just like the satellite, when you launch, everything's got to be perfect. It's got to be able to boot itself up and come up to a clean state every single time. And so you can see us out on the water chasing kayaks and paddle boarders around, and it's been a lot of fun. There's a lot of questions from people on the water of how it gets controlled, and I have to tell the story of me and my laptop of, oh, I'm driving it through a dashboard, and they're very confused. And so the next steps for us, so ideally we're launching in June. So we have to launch with the sun in the right spot in the sky. It's sort of dictated by physics. So every weekend from now until the middle of June, I need to be out there and getting test runs in and doing some debugging. We need to leave here in the summertime to get to the southern hemisphere by their summertime. And so simple physics sort of dictates and gives me a hard deadline. So we're launching in June. So that is Project Bob. And so if you got any questions, feel free to ask them in the podcast. Also follow along on Twitter and the website. Twitter's the best place, and you'll see me tagging the Grafana and Influx and Tailscale accounts as we push out some content. And then we should be live streaming every day of the journey during the daylight hours. So it should be a lot of fun. So huge thanks to all of the sponsors and all the tools that we've utilized along the way. We really couldn't have done it without the wonderful open source tools that we're here to celebrate. So thank you very much.